At right are the graphs of a function f and its inverse. Remember that if the graph of f contains ab, then the graph of the inverse contains b, comma a. Also, the graph of inverse f is the reflection of the graph of f across the line y equals x. From the graphs at right, do you see a relationship between the slope of the graph of f at ab and the slope of the graph of the inverse at ba? If you don't see a connection yet, let's try example 1. F of x is equal to the square root of x. Sketch the graph of f of x. Find f inverse. Rewrite f of x as y equals root x, switch x and y. Solve for y. We must write a domain restriction because root x, the x values, could only be 0 to infinity. So when finding the inverse, that domain restriction also applies to the inverse. Sketch the graph, which we already did. Differentiate both of them. Now let's find the slope of the graph of f at 4, 2 and of the inverse at 2, 4. What conclusion can you make about these slopes? They're reciprocals. Since slope is delta y over delta x, it should make sense that when you switch x and y, as you do for inverse functions, you would switch or flip the slopes. Here are the conditions for this formula. When finding derivatives of inverse functions, do not use the same x value for both f and f inverse. This hardly ever works. It only works when the x and y values of the ordered pairs are the same. Let f and g be inverse functions such that all of this. From that given information, we're going to find this. Creating a table or a chart to organize the data is very helpful for these. So they've given us lots of information about f, and they're asking us lots of information about f's inverse, which is g. I've highlighted the x values that we're looking at for the f graph. Remember that f is giving us the reflected points of its inverse. So we need to switch the x and y values when considering g because it is the inverse of f. And the slopes of the inverse are reciprocals of the slopes of the original. Now our chart can help us answer questions A through E. G prime of 1 is 2/3. G prime of 2 is 1/2. G prime of 3, we were not given enough information to know that. G prime of 0, again, we were not given the image point for 0. G prime of 5 is 2. If a function f has an inverse f inverse, then f is 1 to 1 and must either be strictly non-increasing or non-decreasing, meaning strictly monotonic on its entire domain. We can use f prime to find out where f is increasing and where f is decreasing. Use f prime of x to show that f of x is not 1 to 1 on its entire domain. This is simply the f prime number line. This is not strictly non-increasing because it's increasing on this interval. This is not strictly non-decreasing because it's decreasing on these intervals. Therefore, this function is not strictly monotonic and not 1 to 1. Find the largest interval containing x equals 0 for which f is 1 to 1. Okay, they're looking for an interval where you're only decreasing or you're only increasing. And so at x equals 0, you're only increasing, and that interval is as large as negative root 2 to root 2. The largest interval containing x equals negative 2 would be from negative infinity to negative root 2. Since f prime changes sign, then it's no longer 1 to 1 after that.